Hi everyone, today we are dealing with the problems of exercise 6.3 of chapter number 6, triangles. So the first question is, state which pair of triangles are similar. Write the similarity criterion used by you for answering the question and also write the pairs of similar triangles in the symbolic form. So first you have to state which pairs are similar. Check whether the given subdivisions are similar or not. Then you have to write the criterion with which you are saying that they are similar, and you have to write the symbolic representation of similarity using the triangle concept. Okay, so the first subdivision of the question is triangle ABC and triangle PQR are given and the angles are given. So here you can see, by visualizing only you can get angle A is equal to angle P equal to 60 degree, angle B equal to angle Q equal to 80 degree, angle C equal to angle R equal to 40 degree. That means you are getting angle A equal to angle P, angle B equal to angle Q and angle C equal to angle R. That means what you can say, therefore by which criterion you can say that these two triangles are similar? By AAA. By AAA, that is angle, 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 similarity criterion. The two triangles are congruent. Now which two triangles? We have to write in symbolic way, and you have to just see whether which vertex you are writing that should coincide with the corresponding vertex. Okay, so when we are saying A, it should coincide with P. When we are saying B, it should coincide with Q. And when it is C here in this triangle, the other triangle, it should be R there, and the representation is, this is your symbolic representation. Therefore the two triangles, triangle ABC and triangle PQR, are similar. Okay. Next subdivision 2 is, again you have been given two triangles ABC and PQR with the corresponding sides. So we have to check the ratio, whether the ratios are equal. If the ratios, corresponding ratios are equal, then also we can say that the two triangles are similar by SSS, similarity criterion. Okay, so first let's just check the ratios. AB, if I am taking AB, what shall I take? You just see 2, its double is here. So you have to take QR. How much it is? 2 by 4, which is 1 by 2. And next thing is, if I am starting with B, it is BC. So I have to start this in this triangle with R, RB. Here you can see B, here it is R. Instead of A, it is just correspondingly coming with Q. So BC will give you RP as its corresponding side. So the ratio becomes 2.5 by 5, which is again 1 by 2. And the other thing is CA. If I consider CA, it should be PQ. CA, here C matches with P. So CA will give you PQ as its corresponding side. And it is 3 by 6, which will again give you 1 by 2. That means you can say AB by QR is equal to BC by RP is equal to CA by PQ. Okay. Therefore, by SSS, the corresponding sides are proportional. So we are using by SSS, similarity criterion. Triangle. Now again you have to just go for which side should coincide with which side. Here instead of A we are writing Q. That means when I write A in the triangle, the other side or the other triangle should have Q there. Then for B you have to write R, and for C you are getting P. So you can say triangle ABC is similar to triangle QRP. Okay. third subdivision, again you have been provided with two triangles. Now the three corresponding sides are given. We have to check the ratio of the corresponding sides, whether they are equal or not. Okay, for that we can just start with MP by, when we are taking MP, let's take it as ED. MP by ED will give you 2 by 4, which is 1 by 2, right? Now MP, that is M is matching with E and P is matching with D. Now if we are taking PL, so here you just see P, instead of P we will write D, so DF. Okay, DF, that is again 3 by 6, which is 1 by 2. Now for the third one, which is LM, if you are writing L, for L you are using starting with F. Okay, so F, which one is left? FE. So it is correct. ME, here also ME, LF, LF, PD, PD. Okay, so that is your corresponding way to write the sides. Now what is LM? 2.7 and FE is 5, which is not equal to 1 by 2, right? That means you can say that since MP by ED equal to PL by DF, but this is not equal to LM by FE, the two triangles are not similar. The two triangles are not similar. Okay. Next we will go to the fourth subdivision, which is again, you can just see that two sides and one included angle is given in both the cases. Two sides included angle, two sides included. Now we have to just match them accordingly. Okay, angle M is given to be 70 and here angle Q. So M is matching with Q and both have 70 degree. Okay. Now wherever you write M, you have to write Q when you write the sides. So if it is MN, which is 2.5, which one you will take? It will be 5. Now how to represent it? Instead of M we have to write Q. So we have to write not PQ but QP. Okay. So MN by QP equal to 2.5 by 5, which is 1 by 2. And the other thing you are getting is ML, which is 5. So ML when you write, instead of M here you will write Q. So it is QR. That is your 10. So 5 by 10 is again 1 by 2. So you are getting MN by QP is equal to ML by QR, and one angle also you got, and angle M equal to angle Q, which is the included angle in between the corresponding sides. MN and ML you have in between M as angle, and PQ or QP and QR in between you have angle Q. So you can say that therefore by which criterion? Side angle side, SAS, similarity criterion, triangle. Now which triangle? How to write? When we write M, the other triangle should be starting with Q. Then when we write N, here it should have P, and when you write L, you should have R there. So triangle MNL is similar to triangle QPR. Okay. Now fifth subdivision is, you have been given two triangles in which angle A is equal to angle F is equal to 80 degrees. Now while considering the sides, if I am considering AB, so instead of A I need to write here F. So it will be FD, which is 2.5 by 5, which is 1 by 2. Then the other side is here BC and here it is EF. Now we have already seen that wherever A you have F. Now if I am writing BC, actually I need to get D. Correspondingly I need to write here D. So DE it will be, right? But DE is not here. We have not been provided with this side's length, so that we cannot take like EF and match it with, because F is matching with A. so that we don't have that fraction to be taken here, and hence we can say that the two triangles ABC and the other one are not similar. Okay, this is not EF is equal to 3 by 6, but it is not matching with the other part, which is not corresponding part. Okay, not corresponding sides, therefore the triangles are not similar. Here in physics 1 you have angle, if you are taking angle E, angle Q is also 80. So you can say angle E is equal to angle Q is equal to 80 degree. Then actually here it is given to be 70, and the other side the angle R is given to be 30. So we need to find out what is this angle. Okay, for that we can use the angle sum property. So angle F will be equal to 180 minus of angle D plus angle E by angle sum property. Okay, so you will get 180 minus of 70 plus 80, which is 180 minus 150 or 30 degrees. So you are getting angle F to be 30. Now if F is 30 and you are getting R to be 30, we can say that angle F is equal to angle R is equal to 30 degree. So you got two pairs of corresponding angles to be equal. That means you need not go for the third one. Directly third one will also be equal. The other part, that is angle P, will be 70 only, because 80 plus 30 will give you how much? 110, and 180 minus 110 will give you 70. But we need not go for that because we have another criterion, which is AA. So therefore by AA criteria, similarity criterion, what we have, which two triangles are similar? When we write E, it should be Q, D should match with P, and F should match with R. So it is DEF is similar to triangle PQR. Okay. Question number 2 is, in the given figure, triangle ODC is similar to triangle OBA. Triangle ODC is similar to triangle OBA, and angle DOC is given to be 125 and angle CDO is given to be 70. You need to find out angle DOC, angle DCO and angle OAB. DOC, which is that angle? This DOC is this angle. For this angle, since we have this as 125, you can use a linear pair concept and find out what is DOC. Okay, so angle DOC is equal to 180 degree minus angle BOC, which is equal to 180 minus 125 equal to 55 degrees. So you got DOC, and the reason for this is since it is a linear pair. Okay. Now for the second one, which is angle DCO, just see where it is. DCO means this angle you want. Here you have got this to be 55, means the total sum will give you 180. So again you can use here the concept angle sum property of a triangle, so that angle DCO will be 180 minus of angle, which all angle we will have? This angle, that is DOC, plus angle ODC. Okay, and this is by angle sum property of a triangle. So it is 180 minus of DOC is how much? DOC you have got it to be 55 plus ODC is given to be, or you can say CDO is given to be 70. So you will get it to be again 180 minus 125, which is 55. So angle DCO is also 55. Now you have angle OAB, which is that OAB. That means this angle you want to find out. Okay, For that you can use, since the two triangles are given to be similar, okay, the two triangles are similar means this angle will coincide with this angle. That is, angle OAB is equal to angle DCO. The reason is, since triangle ODC is similar to triangle OBA, and this angle DCO is already 55, so you will get angle OAB also to be 55 degrees. Okay, so all the three angles are 55 degrees each. Question number 3 is, diagonals AC and BD of a trapezium ABCD with AB parallel to CD intersect each other at the point O. Using the similarity criterion of two triangles, show that OA by OC is equal to OB by OD. So they have not given the figure, we need to draw that figure. So we have taken a trapezium ABCD with AB parallel to CD, and the two diagonals intersect at O. The diagonals BD and AC have been taken so that they intersect each other at O. Now you have to use certain similarity criterion which will help us to show that OA by OC is equal to OB by OD. Now when you have this fraction, we will get an idea which triangle we need to consider. Since we have to get this and this, we will consider these two triangles, that is triangle AOB and COD. Okay, consider triangle AOB and triangle COD. Now our purpose is to show that these two triangles are similar so that we can get the corresponding sides to be proportional. Okay, so what all concept we can use? Since these two are parallel lines, we can say that this angle will be equal to this angle and this one will be equal to this one. Why? You can use the alternate angle concept. Okay, now for the triangles you have angle DCO is equal to angle, this is your DCO, and that is equal to BAO. And one more which you can get is this angle, that is CDO. CDO is equal to, which angle you will get? This angle. So it is ABO. Okay, and the reason for these two is alternate angles. Alternate, and these are alternate angles since the two lines are parallel. Now you can say that by which criterion? Only two angles are enough to show that the two triangles are similar. So we are getting by AA similarity, because these two triangle angles are equal means the third will always be equal. And here actually you have one more thing, that is vertically opposite also you can say. So any two angles, if you show that they are equal, you can use by AA similarity criterion. Triangle AOB is similar to triangle COD. So what you will get, therefore the corresponding sides will be proportional. So you will get OA from this triangle, when you are taking OC you will take from the other triangle, is equal to OB, when you take it will be OD. So you are getting OA by OC is equal to OB by OD. Why? Because corresponding sides are proportional. Okay. Now question number 4 is, in the given figure, QR by QS is equal to QT by PR. This fraction, these two fractions are given to be equal, and angle 1 is equal to angle 2 is also given. You have to show that triangle PQS and triangle TQR are similar. So we will start with angle 1 is given to be angle 2. So this is given. And since the angles are equal, the sides opposite to equal angles will be equal. That means this is angle 1, its opposite side is PR, and angle 2, its opposite side is PQ. So you can say that this will imply that PR PR is equal to PQ. Why? Because sides opposite to equal angles are equal. Okay, so this is the concept which we are getting. Now we will consider the two triangles which we need to prove that they are similar. So consider triangle PQS and triangle TQR. Okay, in these two triangles now we will use this concept, that is what is given, QR by QS is equal to QT by PR. This is also given. Now what we are doing is, what we have already got, PR equal to PQ, that we will be replacing here. Instead of PR we will be writing PQ. And this can be rewritten as QR by QS equal to QT by PQ. Okay, this much we got, and this concept we got from, since PR is equal to PQ. Okay, now we will just separately draw the two triangles PQS, sorry, this is PQS and TQR. Okay, TQR. So here the fraction which we got is, just see, QR by QS is equal to QT by PQ. Now if we get one angle in between or the other side, so the option which we have is angle 1 equal to angle 2 was given. So this angle is actually here common. This is angle 1. So in both the cases you have angle Q, or you can say angle 1 to be common. So you are getting, and that is included angle for both the triangles of the sides PQ and QS, this is included, and TQ and QR, this is included. So you can say that this one, and you got angle PQS equal to angle TQR, which is common. You can say equal to 1, angle 1, which is common. Okay. So you got the concept, two sides are proportional and included angle is equal for both the triangles. So you can say, therefore, by which criterion you will get the two triangles to be similar? By SAS, similarity criterion, triangle PQS is similar to triangle TQR. Okay. Question number 5 is, S and T are points on sides PR and PQR of triangle PQR such that angle P equal to angle RTS. Show that triangle RPQ is similar to triangle RTS. For that we need to draw the figure in whichever manner they have told, that is PR and QR sides, PR and QR should have S and T marked on those lines. So this is your S and T, and angle P, this angle is equal to angle RTS. This much is given in the question, and we need to prove that these two triangles. So I am just separately drawing the two triangles which they are preferring, that is RPQ and RTS. Okay, RPQ and RTS. This clear? Okay, so this angle is equal to this angle is given in the question. This much is okay. Now we will start with considering the two triangles separately, that is triangle RPQ and triangle RTS. Here the concept which is given is angle P is equal to angle RTS. So it is given, right? Now again you can see that for both the triangles this is common. Angle R is common, so that we can write angle PRQ, or you can say QRP is equal to angle SRT, because angle P is equal to angle T means you have to take in the opposite direction. R will be in the middle, but you have to check for the sides also. Okay, so angle P means it is coinciding with T. So wherever you write P, it should be T here. Okay, and this is common. So you have got two angles to be equal for the triangle. Therefore, you can apply your AA similarity criterion. to say that the two triangles are similar. Therefore, by AA similarity criterion, triangle RPQ is similar to triangle RTS. Okay. Question number 6 is, in figure, if triangle ABE, this triangle is congruent to triangle ACD, show that triangle ADE, the smaller one, is similar to triangle ABC, the bigger one. Okay, so congruency of certain triangles is given and you have to prove the similarity of certain other triangles. So from the congruency, the triangle is like ABE. So you are getting like A, B, E and A, C, D. A, C, D. Okay, these two triangles are given to be congruent. That means you can say that AB will be equal to AC because they are corresponding sides, and the corresponding sides will be equal if they are congruent triangles. Corresponding sides as well as corresponding angles will be equal for congruency, right? So we will get from the triangle ADE and AC, or you can say that it is given that triangle ABE is congruent to triangle ACD. This is given. So you get AB is equal to AC. AB equal to AC and AE equal to AD. Okay, AE equal to AD. These two concepts you will get by CP, CT. Clear? Now from the same thing, that is AB equal to AC, I can get AB by AC will be 1. And from AE equal to AD, again I will get AD by AE is equal to 1. Right? Now why I have taken AD by AE? Because here again AE by AD will also be equal to 1, AD by AE is also equal to 1. I have written AD by AE because my concept is to show that these two are similar. That means wherever you have AD, you should get AB. So here if I am getting AB, I need to get AD for that similarity concept. Okay, that's why I have taken AD by AE equal to 1. Now since both are equal to 1, I will get AB by AC is equal to AB by AE. Okay. Now we will draw the triangles separately, which we need to show them to be similar. So first is ADE and the other one is ABC. Okay, ADE and ABC. So this is your ADE, this is your ABC. Now you can just see what fraction you have got to be equal. The ratio which we got is AB by AC is equal to AD by AE, right? So two corresponding sides you have got to be, their ratio to be equal. Now you can just see that they have a common angle A, and that is the included angle for both the triangles. So what is the name for that angle? DAE is equal to angle BAC. So this is your common angle. Therefore, by which concept? SAS similarity criterion, what you will get? Triangle ADE is similar to triangle ABC. Okay. Question number 7 is, in the given figure, altitudes AD and CE, AD and CE of the triangle ABC intersect each other at P. And you have to show that first subdivision is triangle AEP, this one, and CDP, the smaller one, this and this. They are similar, you need to show. So for that, first condition which we can say is this angle is 90, this is 90 because they are altitudes. Okay, so you will have angle consider triangle AEP and triangle CDP. Okay, and in that you will get angle AEP is equal to angle CDP equal to 90 degree, because both are altitudes, forming the altitude. So at E it is 90 and at D also it is 90 degree. Now for these two triangles you can just see this angle will be equal to this angle, this one and this one, while they are vertically opposite angles. For that we will get one more angle to be equal, which is angle APE equal to angle CPD. Okay, APE equal to angle CPD. Clear? Reason is vertically opposite angles. So you got two pairs to be equal, therefore you can apply your AA similarity concept to make them similar. Therefore by AA similarity criterion, triangle AEP is similar to triangle CDP. Okay. Now going for the second one, which is triangle ABD. ABB and CBE. So this triangle and this triangle, you need to show that they are similar. So for this you are considering both the triangles ABD and triangle CBE. Here you will get one pair as this will be also 90. That means in this triangle ABD you can get angle ADB. Angle ADB is equal to, from this triangle you will get this, that means CEB. Angle CEB both to be 90 degree. And the other concept which you will get is, you can just see that this B angle is common to both. Angle ABD here and angle CBE, or that will also give you the same angle B. So you can write angle ABD is equal to angle CBE. The reason is common angle. So again you got two angles to be equal. So you can say, therefore by AA similarity, angle similarity criterion, triangle ABD is similar to triangle CBE. Okay. Now subdivision 3 is triangle AEP, the smaller one, and ADB are similar, you need to show. Okay. So for that we can see that this angle HE and angle HD are both 90 degrees. So you will have, with the same order, AEP is equal to angle ADB equal to 90 degree. And again this A angle is common for both. That means this angle is common for the smaller and the bigger triangle. But the order should be maintained, that is A should be in between in the same order. If you are starting with P, it will be AE. Then you need to start with B, BAD. Okay, angle PAE equal to angle BAD. And the reason is they are common in both the triangles. Okay, and the A is common for both the triangles. Therefore, by AA similarity criterion, triangle AEP is similar to triangle ADB. Okay, so the same criterion also follows here in this problem. Next subdivision is triangle PDC, the smaller one, and BEC, this bigger one. These two triangles, we need to show that the smaller and this bigger one, they are similar. For that again you can see that at the point D and at the point E you have 90s. So you can write angle PDC is equal to angle BEC in the same order which they have given. is equal to, that is at D and at E you have 90 degrees. Then which angle is common here? C. So you just see, when you are writing the angle C, it should be in the order. That is, if you are starting with DCP, you should start with ECB. Okay, angle DCP is equal to angle ECB, and the reason is it is common in both the triangles. Therefore, by AA similarity criterion, triangle PDC is similar to triangle BEC. Okay. Question number 8 is, E is a point on the side AD produced of a parallelogram ABCD and BE intersects CD at F. Show that triangle ABE is similar to triangle CFB. So first we need to draw the figure, then only we will know what we need to prove. Okay, so what we have is, you have to get a parallelogram ABCD. Okay, so I will just draw here ABCD parallelogram. And you have to extend, see, E is a point on the side AD produced, so extend AD, this is A, B, C, D, extend AD so that you can take a point E somewhere here, and then you have to, in BE intersect CD at F, means you have to join BE such a manner that it will intersect somewhere at on the line CD, and that should be taken as F. Okay, so this is the figure required for this problem to be solved. Now you can see that this is a parallelogram, and since ABCD is a parallelogram, you can just say that angle A will be equal to angle C, because opposite angles of a parallelogram are equal. So that is one concept, and the other concept which we will have is alternate angles concept. Okay, so if I am taking this angle, that will be equal to this, that is angle A equal to angle C you will get, and this angle equal to this angle you will get. So the two things are enough to show that the two triangles are similar. Now how we will prove is, we will start with ABCD is a parallelogram given. Since ABCD is a parallelogram, we have angle A equal to angle C, because they are opposite sides of a parallelogram, and opposite sides of a parallelogram are equal, right? So that is one concept. Now we are just going for the triangles which we need to make similar. So consider triangle ABE and triangle CFB. Just see, ABE and CFB, these two. Okay, so angle A equal to angle C in the parallelogram, we will just shift that angle or rewrite that angle in terms of these. Okay, so what we will get, that is angle, in order to write angle A, we will write it as EAB. Angle EAB is equal to angle C, can be written as BCF. Angle EAB equal to angle BCF. So this is actually from first equation. Same concept which we have already told, right? And the next concept which we will get is, this angle is equal to this angle. What is this angle? This is your ABE, and this angle is your CFB. So angle ABE is equal to angle CFB. Reason is they are alternate angles, since you have your AB and CD or DC to be parallel. Okay, alternate angles. Therefore, you have got two pairs of angles to be equal. So you can say that by AA criterion, similarity criterion, triangle ABE is similar to triangle CFB. Okay.